Hello everyone, welcome to our first video. Today we're going to learn about trigonometric identities. We're going to learn how to simplify trigonometric expressions and then how to verify trigonometric identities. So a key term today is trigonometric identities, which is just a simple way of saying an equation that involves a trig function that is true for all the values of the variable. Our very first trig identity is the reciprocal identity. Those just simply state that we can rewrite cosecant of x as 1 over sine, and secant of x as 1 over cosine, and cotangent of x is simply 1 over tangent of x. We can also rewrite tangent of x as sine of x over cosine of x. Therefore, cotangent of x is simply cosine of x over sine of x. Example 1. Let's simplify the expression sine of theta times secant of theta. I'm going to use our reciprocal identity for secant of theta. I can rewrite secant of theta as 1 over cosine of theta. So now I have sine of theta times 1 over cosine of theta. Or if I multiply across, I get sine of theta divided by cosine of theta, which using our tangent identity is simply tangent of theta. Okay, now let's look at how we would verify trigonometric identities. First thing you want to do is trigonometric identities involve equations. So now we have an equal sign. We have some trig function equal to some trig function. And we want to rewrite one side of the equation so it looks like the other side, using our identities that we've learned previously. One thing you'll need to do is figure out which side of the equation is easier to work with. My suggestion to you is always pick the more complicated side, because it's easier to make something complicated simple than to go the other direction. Once you pick the side of the equation to work with, now you're going to need to start using your trig identities to rewrite that side of the equation. And also, we'll use some of our algebra rules, such as finding the common denominator, factoring out our GCF, and simplifying equations. If you should ever get stuck, one helpful thing to do is try rewriting all trig functions in terms of sine or cosine, and then simplify down. We'll retry our first verification problem. There's a couple more identities I want you to know, and these are very, very important. You'll use them quite often, and they're called the Pythagorean identities. First off, sine squared of x plus cosine squared of x is equal to 1 is your basic Pythagorean identity. The other two Pythagorean identities is just that equation rewritten. For example, if I divide each side of the equation sine squared of x plus cosine squared of x equal to 1, if I divide each side by sine squared of x and simplify down, I will end up with the second Pythagorean identity. If I take the original Pythagorean identity sine squared of x plus cosine squared of x equals 1, and I divide each side of the equation by cosine squared of x, it would simplify down to our third Pythagorean identity, which simply states tangent squared of x plus 1 is equal to secant squared of x. Be prepared to know that you will often have to rewrite each of these equations for some substitution. For example, I could rewrite this second Pythagorean identity as 1 minus cosecant squared of x is equal to negative cotangent squared of x. Sometimes you'll need to do this in order to substitute in your Pythagorean identities. Example 2. Verify the identities. So let's look at Prot A. We have tangent squared of theta minus sine squared of theta is equal to tangent squared of theta times sine squared of theta. Now remember, our first step on verifying is to figure out which side of the equation we're going to work with. And we want to choose the most complex. I'm going to choose the left-hand side here because I have a subtraction. Addition and subtraction is always more complex than multiplication. So that's the reason why we should work with the left-hand side. First thing I notice, I have tangent squared of theta. Let's rewrite that using our tangent identity. I'm going to get sine squared theta over cosine squared theta minus sine squared theta over 1. Now let's subtract by finding a common denominator. We're going to multiply the second fraction by cosine squared and then combine this into one single fraction. Next, on the numerator, I notice I have a GCF of sine squared theta. So let's factor it out. Inside the parentheses, I have 1 minus cosine squared of theta. Anytime you have 1 plus or minus a trig function squared, think of the Pythagorean identities. So the Pythagorean identity that involves 1 and cosine squared of theta is 1 is equal to sine squared theta plus cosine squared theta. So I'm going to rewrite this so I have 1 minus cosine squared. So I'm going to subtract cosine squared from each side. And it leaves me with just sine squared of theta. So in place of the 1 minus cosine squared theta, let's substitute in sine squared theta using our Pythagorean identities. So let's rewrite this fraction as sine squared of theta over cosine squared of theta times sine squared of theta over 1. And then using my tangent identity, I can rewrite that as tangent squared of theta times sine squared of theta. Now I have the left-hand side of the equation equal to my right-hand side of the equation, and I have verified my first identity. Please pause the video at this point and try working out problem B by yourself. When you are done, come back and push play. Alright, let's see how you did. Hopefully you recognize that the right-hand side of the equation is the more complex equation. So let's work with that side. And since I have two fractions and I'm subtracting, I need to find a common denominator so I can subtract the two fractions. I'm going to choose my common denominator to be 1 minus sine of x times 1 plus sine of x. For my first fraction, that means I need to multiply the top of this equation by 1 plus sine of x. And for my second fraction, I need to multiply the top and bottom by 1 minus sine of x. If I subtract these two fractions, I get 1 plus sine of x minus 1 plus sine of x over our common denominator. I'm going to use full and go ahead and multiply the denominator together, and I'll end up with 1 minus sine squared of x. Simplifying the top, we end up with 2 sine of x divided by, now looking at the bottom, I have 1 minus sine squared of x. If I rewrite my Pythagorean identity, sine squared of x plus cosine squared of x equals 1, I figured out that 1 minus sine squared of x is the same as cosine squared of x. Next, I'll break up this fraction and rewrite sine over cosine squared of x as sine over cosine of x times 1 over cosine of x. And using my tangent identity, that becomes tangent of x, and my reciprocal identity times secant of x. And now I have the left-hand side equal to the right-hand side. And I have verified my second problem. Sometimes when we're working out the first three steps of verifying problems, figuring out which side of the equation to work with, using our algebraic skills and identities to simplify it down, we might get stuck. And one little trick that you need to use in algebra quite often is multiplying by 1. You will find that trick comes in very handy when you're solving trig identities as well. At this time, please try to solve example 3 on your own. Pause the video, and when you're done, come back and let's see how well you worked it out. Alright, let's see how you did on problem number 3. As you can see, I have addition and subtraction on both sides of my equation. So to figure out which one is the more complex, I noticed the left-hand side also has division. So we're going to work with the left-hand side of the equation. First thing I notice is I have 1 minus sine of theta. As from my previous example, I saw that if I could get 1 minus sine squared of theta, I can use the Pythagorean identity. We're going to decide to multiply by 1 in this problem in order to get that Pythagorean identity. I'm going to choose my 1 to be written as 1 plus sine of alpha over 1 plus sine of alpha. Multiplying through, I find the bottom will simplify down to 1 minus sine squared of alpha. And by design, 1 minus sine squared of alpha using our Pythagorean identity is the same as cosine squared of alpha. Now look, I have a cosine of alpha on the top and a cosine of alpha on the bottom. We can simplify that down to simply cosine alpha on the bottom. Now let's break up this fraction. And then using our reciprocal identities, 1 over cosine of alpha becomes secant of alpha. And using our tangent identity, that becomes plus tangent of alpha. And our left-hand side is now equal to our right-hand side. We have verified this problem. As I hope you recall from last year, sine and tangent are odd functions, whereas cosine is an even function. So that's where these even-odd identities come from. Since sine is an odd function, when I plug in the opposite of x, I get the opposite y. So that means that sine of negative x is equal to negative sine of x. And the same thing is true for tangent. Tangent of negative x is equal to negative tangent of x. But on the other hand, cosine is an even function. So cosine of negative x is just simply cosine of x. Finally, let's look at some cofunction identities. This just simply states that sine and cosine are cofunction identities, just like tangent and cotangent and secant and cosecant. So sine of pi over 2 minus u is equal to cosine of u. And its opposite is true. So if I take cosine of pi over 2 minus u, that's equal to sine of u. And the same thing is true for all other cofunction trig identities, such as tangent and cotangent and secant and cosecant. Now it's time for you to try it yet again. So pause the video and try to solve this verification problem. When you're done, come back and let's see how you did. Let's see how you did on this problem. Now this was pretty easy to see that the left-hand side was much more complex than right, so we're going to work with the left-hand side. The first thing that glares at me is I have a sine of negative x. So I'm going to use my odd identity and replace that with negative sine. Okay, I'm a little stuck here. So when I'm stuck, let's try rewriting everything in terms of sine and cosine. So I'm going to rewrite cosecant of x as 1 over sine. Since my right-hand side doesn't have any minus signs, it only has a single term, let's subtract these two fractions by finding a common denominator. Our common denominator is going to be sine of x. And so therefore, my new numerator for the second fraction is going to be sine squared of x. Subtracting the two fractions, I end up with 1 minus sine squared of x over sine of x. Oh, there's 1 minus sine squared of x. That's a Pythagorean identity I hope you've started to learn to recognize. So I'm going to replace that with cosine squared of x. And now let's multiply these two fractions together. And finally, let's use our cotangent identity. I hope you were successful in solving this last example. Go back through and look at all the identities we've learned in this section and start memorizing them, because we'll be using them a lot next class period.